Theorem: show that a linear operator T is unitary if and only if it maps orthonormal basis. Proof: let T be a unitary operator on a finite dimensional inner product space V, which employs T preserves inner products. Since we know that every finite dimensional inner product space possesses an orthonormal basis on V is finite dimensional, so V has a orthonormal basis. Let B equals to alpha 1, alpha 2 and so on alpha n is an orthonormal basis of V, then we shall show that T of alpha 1, T of alpha 2, so on T of alpha n is an orthonormal basis of V. For k equals to 1, 2, so on n and j equals to 1, 2 and so on, and we have T of alpha k, T of alpha j equals to alpha k, alpha j. Since T preserves inner products equal to delta kj, since alpha k and alpha j belongs to B, and by the definition of orthonormal basis, so T of alpha 1 and so on T of alpha n is an orthonormal set in V. Since T is isometric isomorphism which implies T is invertible, so it is non-singular, which employs T of alpha 1, alpha 2 and T of alpha n is linearly independent, consisting of n elements, which is the dimension of V. Hence T of alpha 1, T of alpha 2 and T of alpha n constitutes a basis for V. Conversely, let T be a linear operator on V such that alpha 1, alpha 2 and so on alpha n and T of alpha 1, T of alpha 2 and so on T of alpha n are orthonormal bases of V. Then we shall show that T is unitary, that is T of alpha 1 and T of beta equals to alpha beta. Now let alpha equals to sigma I varying from 1 to n xi alpha I and beta equals to sigma j varying from 1 to n yj alpha j. So alpha beta equals to sigma I varying from 1 to n xi alpha I sigma y j varying from 1 to n yj alpha j equals to sigma I varying from 1 to n sigma j varying from 1 to n xi yj bar alpha I alpha j. By the linearity property summing with respect to j, all the terms will vanish because alpha j alpha I alpha j equals to delta ij except when j equals to I, then alpha I alpha j equals to 1. So alpha beta equals to sigma I varying from 1 to n xi yi bar. Equation 1. Also T of alpha T of beta equals to T of sigma I varying from 1 to n xi alpha I and T of sigma j varying from 1 to n yi alpha j equals to sigma I varying from 1 to n xi T of alpha I and sigma j varying from 1 to n yj T of alpha j equals to sigma I varying from 1 to n sigma j varying from 1 to n xi yj bar T of alpha I T of alpha j by the linearity property equals to sigma j I varying from 1 to n, sigma j varying from 1 to n xi y j bar delta I j, because T of alpha k and T of alpha j equals to delta kj. Summing with respect to j, the terms vanish because T of alpha I, T of alpha j equals to delta I j, which implies T of alpha I, T of alpha j equals to 1 when j equals to I equals to sigma I varying from 1 to n xi y I bar. Equation 2, from 1 and 2 we get T of alpha, T of beta equals to alpha beta, which shows that T preserves inner product, hence T is unitary.